Hello again, and welcome to our first episode of the Enterprise Linux Security Show for 2022. I'm here as always with Zhao. How you doing?
All good, Jay. Pleasure as always. And yeah, Happy New Year to everybody that's listening in. And it's going to be another fun year, both here for the podcast and for the security world at large. It's not going to get better. That's the spoiler.
Yeah, that's the thing about security. You know, if you're in the security industry, well, I guess we all are, whether it's voluntary or not, whether it's our job title or not, we're all involved in this, and it's the gift that keeps on giving. And part of our conversation today is going to include a little bit about Log4j, which also is the gift that has given quite enough already, if I should say so myself. I think we've had enough, but it keeps on. There's new news. We mentioned last time that we would probably have some errata to cover, but it kind of seemed to slow down a little bit over the holidays, but it didn't stop necessarily.
No, it's probably just people going out on vacation and not noticing it at the time.
Right.
But yeah, it keeps on giving, and it's probably going to continue giving throughout the whole year as more new stuff is discovered around it. And in the time since it was announced, there have been 5 new CVEs around it. It's not exactly the original issue, but 5 new ways to exploit Log4j or stuff right around Log4j. Google did a quick survey of the packages on Maven. Maven is a Java repository. 17,000, that's when 7,000 packages were found to be related to Log4j in one way or another by pulling it in as a dependency. And then in addition to that, they found another 400 packages that did not have Log4j explicitly as a dependency, but they did it a bit trickier. They actually had the Log4j source code included in their own project, so it would be compiled within. So it wouldn't show as a dependency, but the code was still there. They are still vulnerable. They wouldn't be picked up by the usual, the usual software that you could use to scan the repositories. It wouldn't show up on the software bill of materials, but it would still be there, and they would still be vulnerable. So over 17,000 packages, it's a lot of packages. And remember, those are not the end products. Those are just stuff that developers will then pull and use on their own stuff. It's a lot of software that's affected by this.
Yeah, there's going to be a ton, especially, what's going to be legacy, which is kind of new-ish, but has kind of, the affected versions in it, but they don't upgrade. It always makes me squirm when, it's like you developed it with which version of that library from when exactly? So it's just going to keep on happening repeatedly.
Yeah, and over time you're going to have this massive database of versions that are just blacklisted everywhere, but are still used in appliances and devices that are already deployed that have never seen an update on their lifetime and probably will never see one. And those are the ones that the hackers will be searching for and scanning for. So yeah, now would be a great idea if you don't have an up-to-date inventory of everything that you have attached to your network. Get one and try to scan it for vulnerabilities. There are some scanners out there that can find some versions of Log4j. Try to run those on your devices and see if anything comes up. It might be a good idea to update those inventories.
Yeah, it is important that you find out first before someone you don't want to find out that you're vulnerable, because that would be very bad. So that's why people listen to this podcast, so they can kind of know what they should be scanning for. What's the most current, oh my God moment. Right now it's this. We're talking about high availability today, by the way, but, of course, I think this is going to be a continuing trend where we start the show kind of just talking about what's going on in the industry before we do our deep dive into the topic at hand. And I'm assuming this year there's going to be some episodes where we won't even be able to get to the topic at hand because there's going to be way too much news to talk about.
Absolutely. And just a quick update on the last story that we ran on the podcast on the last episode. I believe we talked about the UKG group being hacked and going to take 3 weeks to recover everything. It appears now that that attack happened because of Log4j. So they had that on their infrastructure somewhere, and the attackers got in through Log4j. Another interesting thing that came out about Log4j was released by Cloudflare Cloudflare, I'm sorry. Cloudflare is a caching service that millions of websites use. So they have a pretty deep pool of logs that they can rely on and analyze to find patterns and find attack behavior and all that. So they went back to their logs and they found out that there were traces of initial exploits and initial scans as early as December 1st. That's 8 days before the public release of the vulnerability. So yeah. You can't you don't have a way to protect your systems from something that you don't know is a risk. So yeah, sometimes these things like this happen, and who knows how many vulnerabilities are out there that will never be divulged, and hackers have access to them, or attack groups, or I don't know, nation states or whatever. So again, the best thing here to protect your systems from this is like, leave as little open as possible, leave as little exposed to the outside world as possible, update as often as you can, and try to keep up with the news. But even then, it might not be enough. Just try your best. Unfortunately, it's the best advice that we can offer.
Yeah, which, I mean, it's all about keeping your eye on things, and also about, and it's really important to understand what to do when things go wrong and have a plan, because that's the thing. You're never going to think of everything, ever. It's just not going to happen. You're not going to predict everything. Don't even try it. Don't even think about that. Always stay ahead as much as you can. Read the news, do your scans, do your updates, pull everything back. Don't expose what you don't need to, but also be ready to delete and, regenerate if as necessary, if that's something you can do. If you could spin up servers, if you have automation in place, that'll definitely save you the work of building everything manually. So at least you can get back up and running after you figure out exactly what went wrong. So yeah, it's just a job that never ceases to be fun.
Yeah, absolutely. And at any point in time, there's no such thing as 100% secure. You're just as secure as you humanly can, but that's not 100% now, and will never probably be 100% security. And if someone is going to sell you a product that says that you're going to be 100% secure against something, take a good look at it. There's some catch there. There's some asterisk somewhere. They're not telling you the whole story, because that's impossible to guarantee by anybody. Nobody can assure you 100% security.
That's so true. That's I think I'm going to butcher this quote, but a book I've read back in the day, actually it wasn't back in the day, it wasn't that long ago, called Demon, where it said something about the rules of perfect security is don't own a computer, don't turn one on, and don't use one.
Yeah, that's pretty good.
Those are the 3 rules of perfect security right there. If you follow those 3 rules, you will never have a security problem ever, guaranteed.
Unless your data is in a system somewhere that gets hacked by someone else. So yeah, even then.
I think Gilligan on Gilligan's Island was the safest person ever from security threats, right? Because you couldn't even get internet out there, so couldn't even call home. Yeah, lots of fun stuff. Okay, so did we want to talk more?
This is going to be another full year. Every year for the past 5 or 6 years, we've had more CVEs being announced than the year previous. And that trend is probably not going to stop or be inverted soon enough, as more people are looking at the code, more security researchers are looking at code, more money is being poured into programs for bug bounties and bug hunting and all that. So this will probably continue throughout this year and the next, and for the foreseeable future. This will just continue. The trend will just continue, and you have to stay updated on the news.
Do you think that it's possible, and this might be obvious, but just, thought experiment, that the pandemic itself is going to, or maybe has caused, more CVEs to be discovered because more people are at home, they could, if hopefully people aren't unemployed, because I don't wish that on anyone, because there's all different kinds of different employment situations right now with more people home. Almost wonder if that means that more people are poking at things, trying to, get that money from a bounty or something, or they just are taking a fascination into security because of a job transition. Do You think that has anything to do with it, or?
That may have. Bored people are pretty dangerous, especially regarding security.
Yeah.
So you don't want bored people with the knowledge to do security penetration testing and all that to be bored at any moment, or they will start picking at stuff. But
Yes.
other than that, the pandemic did bring something new to the table. There is a whole new set of attack surface that has opened up with people being working from home. You have the VPN connections, and you have the people that forget to turn on their VPN connections and still connect to their workplaces. You have not so good password hygiene that used to be restricted to inside of the network perimeter before, when everybody was working inside the building, but now people are connecting to the services through the internet. And they're still relying on the same password policies, basically. So the attack surface exploded with people working outside the office. They're no longer just inside the network. You don't just have to worry about people getting into your network and attacking from the outside. Your own users are outside. So that's a new vector for attacks. And I believe it's probably both of those issues working at the same time. At the same time, there is further reward for people to look for vulnerabilities, both from the white hat communities, the ones that are doing that to find the issues and solve them, and for hackers, because with the rise with cryptocurrencies and all that, they have a quicker access to monetary reward from their attacks. So they have more incentive to discover new vulnerabilities and new ways to attack systems. So yeah, all of those things put together, that translates into an increased risk for any system, basically.
Yeah, well said. Yeah, that's absolutely the case. So are we ready to talk about our high availability topic?
Yeah, I believe so.
Are we ever ready?
That.
There's so many different edge cases and quirks around that.
I mean, we could look at all the new variants around Log4j, but it's basically the same thing. You're going to have to upgrade Log4j. You're going to have to look at your packages to see if it's pulling it or using it in any way. And you're probably going to have to update that package many times in the coming weeks. It's not just going to be a one-time issue and be done with it. Be prepared to update your applications if they depend on it. And we will probably get back to this.
Yes, I think we will. I think we will. All right. So high availability. So there's different angles that we could take with this conversation, because there's actual benefits. There's, conceived benefits that might not be true. There's quirks. It's not infallible. I feel like people often kind of make it out to be better than it is. But before we talk about that, we should define what high availability actually is, and then we'll just go on from there.
Yeah, so this is not a textbook definition by any stretch of the imagination, but a highly available system is a system that's usually does not include a single point of failure. What this means is that it has duplicate behavior, it has duplicate configurations, it's probably in separate systems, and it's oftentimes used for load balancing when you have multiple systems with the same service running on them, and you can divide your traffic across all of those systems in a transparent way to the end user. So when you connect to Amazon, for example, and on the next PC, your wife connects to Amazon as well, it's assured that both of you will not be hitting the same endpoint server on the Amazon side. You may even be on different data centers for those services.
Yep.
And that's one way that large-scale systems are architected, are prepared to be run. And if one server that's supplying that service to the end user goes down, I don't know, a PSU burns, something breaks, it somehow fails, it fails in a way that's transparent to the end user. It will just continue running. The service will still be available even with that failure point. And in situations like Amazon, you can have multiple failures at multiple different locations, and the service will still continue to run. This is not infallible, however. And continuing with the Amazon example, just a few weeks ago, Amazon US East 1 instance was down for like 7 or 8 hours because they had some power issues or whatever. And it took down a lot of services. It took down a lot of websites across the internet because they were all on that instance. They were running behind highly available systems, but still it was not enough. Okay, so
Right.
this is great. This is what allows you to scale so well your services when you're using containers, for example. But it's not infallible. And like you said, there are some pros and some cons to this. It's obviously the load balancing. It's obviously the availability. It's obviously the ease of use, the scalability that it offers. But then there are some drawbacks that we will get to in a few minutes as well.
Right. So to set, there's a few examples of high availability just to kind of set the stage, or to walk everyone through this. So first of all, if we look at a hardware high availability situation, and we're not talking about cloud now, we're not talking about virtual machines. Let's just say you have 2 physical servers and you have a physical load balancer. And it's set up such that both of those servers are identical. Like you mentioned, a user could access the site. They're accessing server A today, and the next time they go on there, they might be on server A, they might be on server B. But they're synchronized, so it doesn't really matter which one the person is on. The user doesn't really know. It's just the website. They don't really understand how many identical servers there might be behind it. And like you said, if a power supply burns out, motherboard fails or something like that, you have that other server that people will be routed to. Now, here you start to look at some pros and cons, right? So you're not down technically, right? Because you have that one server is down. So everyone's going to server A while server B is, out of commission currently, which is good because you're not down. The problem is that now all of your users are going to server A, and server A has to handle every single request that used to be split between the 2 servers. So if your server is really good and it the bandwidth isn't higher than its capability, it might be a little slow, but it's fine. At least it's not down. And then you could get that other server up and running and then restore that. Another issue there too is that depending on the timeout, you could have a situation where you go to a website and you get an error message when you're trying to go to the website. Even though it's highly available, the load balancer might have a certain window of time where it has to be offline. So it doesn't mean that your users are never going to get an error message, but it is better than being down completely, which is what it solves. And then you think about the cloud situation, because when it comes to cloud computing, you have obviously you have your physical infrastructure, but then you have your software implementation or version of that. So for example, you have hardware networking, you have your switches and your firewalls and your cables. And then on the cloud side, you have software defined networking. So you're just having an abstraction of that is acting the same way as networking works, because it is TCP/IP networking, but it's a virtualization layer. Now, high availability in the cloud means it's easier to have additional servers, whereas physical servers, you have to actually physically, you have to buy a server. If you want 5 servers, you have to buy 5 servers. So when you start to go down that rabbit hole, which I am also going down right now, there's just so many different layers of ifs and what ifs and all these different quirks that you have to take advantage of, to where I feel like a lot of people, and we'll get to this in a few minutes, they over build these things. Like they spend so much money on high availability that they're spending more money than they would actually save. Otherwise, it's just kind of a very chaotic thing. But don't get me wrong, high availability is good. I think one of the things we talked about wanting to do is kind of set the expectations in this podcast so we don't make it a fanboy episode, which we're clearly not ever going to do. And be honest about it. And there's pros and cons.
Yeah, absolutely. What you said before about one server staying up and all that, and taking all of the load, that's going to take a performance hit. And that performance hit may be more or less noticeable depending on the actual capacity of each of those servers. What usually happens when you have a 2-node highly available service, and on premises, it's actually pretty common to have a 2-node highly available system. You want to be able to take one down for maintenance, for example, while the other assures the load. there are two ways you can approach this. You either overspend on each of the servers to compensate for the period of time where they will be taking the whole capacity and be running at maxed out capacity to continue to serve this service that you have, or you pay less for each of the servers because together they can assure the whole capacity. In that situation, when one of them goes down, there's performance degradation, and it will be noticeable to your end users. The pages will load slower, the database will serve less requests, whatever is running there will just be slower. You're asking more of it than it can deliver, basically.
Yep.
But the main issue I see there, and not just me, but is something that even the software vendors sometimes rely on. For example, MySQL, on their own documentation, they have for the highly available scenario, they say that it can be used to support upgrades of each of the nodes without bringing the database down.
Yep.
The point that they fail to mention there is that during that operation, when you only have one node up, you're no longer highly available because that node now is your single point of failure. When you're doing maintenance on one node, and Murphy's Law being what it is, that's when you're going to have issues on the node that's still up, either because you didn't notice that it's not able to take all of the users that you were expecting, or there's a spike in traffic somehow, or something fails at exactly that point in time. You're no longer highly available, even if you're on a cluster, because one of the nodes is down for maintenance, the other one is assuring the load. If that one fails, everything fails and the service falls. And that's the situation you want to avoid at all costs. So
yep.
There are ways around it. You can have more nodes to ensure that there's not only a single one up at any point in time, but again, you will be spending more money. You will have a more difficult to maintain architecture there. There's more moving parts in the whole system. So I tend to consider that the vendors that have this type of instructions on their documentation, and it's more than MySQL. It's not just MySQL.
Right.
Some vendors hide their processes behind this because most of the time things will work fine. Basically, you have that node that if it doesn't fail, nobody noticed that you perform maintenance and the service will keep running. I've written this before. High availability covers for a multitude of sins, and it covers for this one specifically. But you're using it wrong if you're relying on it just for maintenance. If you have high availability just for cover for your maintenance operations, you're doing something wrong there. Either it's the planning that doesn't account for proper maintenance operations to be executed, or you're just not considering the issue of no longer being highly available in that period. And sometimes things go wrong, and that's the times then you'll have more work to do than you would otherwise have. So there are ways around this. You should rely on other best practices. And here we fall in the same rabbit hole.
Yeah, we do.
We do, and we try to avoid that. So you didn't hear me say best practices, but don't rely on high availability to cover for your maintenance operations. If you have highly available systems, that's to cover for failures that you are not expecting. For planned operations, for planned stuff, you should have other mechanisms in place. For example, for updates, you should rely on live patching, for example. And here I'm going to shamelessly plug TaxCare services, because we do offer live patching, and we offer live patching for a multitude of services, including databases. But it's sometimes tricky to get this message across precisely because the vendors themselves advocate this. Again, they don't tell you the whole story in their documentation. They don't tell you the whole issue that may arise for relying on high availability alone for this. But those issues are real, and if you have ever tried to perform that operation and it took longer than expected, then you might have encountered this issue and this situation, and you don't want to be there. We were talking off camera how annoying it would be to replicate data between nodes on MySQL. And yeah, that's an issue that sysadmins and database admins have to deal with when things go wrong.
That's exactly right. That's a really great description. And one of the things you said also, as an aside, was it works most of the time, which I kind of feel like that's the unofficial slogan of IT, right? It's like, yeah, IT, it works most of the time. Because
Fedora Rawhide, sorry for cutting
yeah,
you off. Fedora
no worries.
Rawhide, the absolute bleeding edge branch of Fedora, used to have this tagline a few years back: "Some days it even works." I always
Oh,
found that amazing. And yeah,
that is
IT is
great.
mostly like that. Some days it even works.
Yeah. So a couple more examples, leading through this. Because I feel like, cost is obviously a big factor. You brought that up. And if you have just two servers, like I mentioned in my example, two physical servers, a hardware load balancer, like I mentioned, one of those goes down, then you have all your people, all your users on the other server. So what do? Maybe you buy a third server. You need, two to be
Mhm.
comfortable. Three, you don't really need the third one, but you buy it because now one server can go down and there's really not going to be much of a problem because you
Mhm.
only ever utilized maybe 75% of two servers, but you have this third one, but you had to buy the third one. And now when it's time to upgrade, when the hardware's end of life or whatever, you have to replace three servers now. When the hardware load balancer is end of life, you have to replace that too. So now you have all these different things to replace. And if you over engineer it to the point where you have like 10 servers, oh my gosh, like now you really have some cost when it comes time to replace hardware. And you certainly don't want to be in a situation where you have on-like hardware, because then it's not really the same thing. And you're hoping that
Yeah.
it's not your best server that falls down first, right? There's all these
Mhm.
different categories. But then again, you'll appreciate that if it saves you, if one server does go down and nobody notices. It's like, cool, that's really cool.
Yeah.
But it's also really expensive, and there's part of the problem. And you don't want to over engineer it to the point where you have a load balancer in front of your load balancer in front of your load balancer going to several different things, and you have like cold or warm sites where you have to buy hardware that you just hope you never have to use,
Mhm.
or hardware that's online all the time, wasting power, that's just
Yeah.
there in case you need it. And that's all physical. I haven't even gotten into cloud yet. So
Yeah.
that could be a really expensive thing to deal with. And you have to ask yourself, like, what is the cost of the downtime versus how much you're spending on your, staff to maintain this and the hardware that you have to keep replacing. And the other thing too is that, um, when it comes to some CTOs, you tell them, yeah, the site never went down. Great, perfect. Why did we lose sales then? Because the remaining servers were just so slow that nobody could finish the checkout process on the online
Yeah.
store. So even though the site was never down, people couldn't buy anything, but at least it wasn't down, though. We could check that box.
Yeah, if the metric is just the 5 nines of uptime, you're going to hit them perfectly, but the service is unavailable or unusable. So, yeah, you might as well not have hit that mark and be transparent about it. And it's
Right.
interesting that you mentioned the hardware load balancer going out end of life. A few years back, lots of them went end of life when certificates suddenly had the key size double,
Mhm.
because when a key size doubles, it means 4 times the work for the load balancer on each request. And some of them just couldn't take the handle of HTTPS when the certificate key size doubled. So lots of them were appearing on eBay a few years back. At the same time, bunches of them, they were pretty cheap to buy, just because the certificate key size increased. And that is going to happen at each new key increase.
Yep. There's going to be changes. It's going to be,
Yeah.
especially when they sunset the operating system of the device. And, it's still
Yeah.
a good device. It's just
Mhm.
technically it's not receiving updates now. So you have the
Yeah.
same problem as you would have with the manual or HA proxy system that you built yourself. If you have to replace everything, you replace everything.
Yeah.
Um,
And it's interesting to mention HA proxy as well. Most of the hardware load balancers will just be running HA proxy inside, and they will have this nice web UI for it. But at the core, it's HA proxy. That's an amazing piece of software as well. And it's used on most of the hardware load balancers, except for the very expensive top of the line ones. And most often, HA proxy will do the work properly of one of those.
yeah, absolutely. And when we get into cloud, originally we start to have the same problem exactly. The only difference at first is that you're not buying the hardware, you're using someone else's hardware. So you have a software manifestation of a load balancer and a virtual machine, and you have software defined networking. So now you have a data center and you have like no actual hardware, physical parts that you maintain. But you still start with the same problem, because if you have a cloud provider and you have two servers, doesn't matter if they're two virtual machines in a cloud environment or two physical machines in your physical server, there's still two machines. If you have just one load balancer, you still have one load balancer. The only difference, again, is that you didn't buy the hardware. You don't have to worry about sunsetting the hardware, and that is a benefit for sure. But cloud isn't the answer to all things, like some people would make it out to be. It's a great tool. But it's something that we have to talk about, because that's the logical next step. What about the cloud? It can get better, and there's some abilities in the cloud that are easier, because we had manual scaling when my career started, which means if you had a server go bad, you manually pulled it out of the rack, you manually put a new one in, and if you wanted to scale horizontally, you went to the store, hoping that there is a store near you that sells servers, or you order one, and then you just put it in the rack, and that's how we scaled. It was manual scaling, which is the way that it was, right? That's how it started.
Absolutely.
And now we have auto scaling in cloud, which is not in and of itself high availability, but it's another layer, which I'll get to in a few minutes, that can make it better. But when you first start with cloud, you have the same issues. It's still going to be, the load is going to be an issue if everyone's going to one server or you have too few servers. I wanted to segue though and talk about automation, because I feel like when people look at high availability, or CTO receives a white paper, like, we got to have high availability, that becomes an obsession. It's like, we got to do this. It's very important. And yes, it's important, but don't do that instead of something else that you should have been doing, like having a disaster recovery plan, or getting your automation set up to where you can, provision the operating system, your application, everything from scripting, so that you don't have to do so much manual labor over a course of hours to get a server built up. Don't negate that in favor of high availability. You have to have a balance here. And in my opinion, I don't know if you agree or disagree, I think automation is a bit more important, actually.
Yeah, absolutely. Because with automation, you can underpin all of these systems. You can rebuild all of them if you have the proper scripts in place or stored somewhere that you can quickly access to in case everything falls down unexpectedly. You can recreate all of this environment, even the load balancers themselves, if you're relying on HA proxy being on your systems, or I don't know, if you rely on the cloud itself and you have all of the service descriptions, all of the scripts to pull it back up again, then great, that's your disaster recovery plan right there. This is just another part of the architecture. Instead of relying on one single web server, for example, you can have 10 instances running with the same web servers running the same websites, and they're just behind the load balancer, and when it comes up, it has the same capacity, all the users are happy again, and it's much easier to get everything back together again and back up running. Automation gives you the speed and the certainty that you're going to have the same environment over and over again. So it's probably the best disaster recovery solution, is to have everything created from software and defined by software scripts, be it Docker, Compose files, be it Ansible scripts, be it whatever. That's a great way to do disaster recovery. And automation can give you that basically for free. When you're setting up the initial services, just store the configuration files.
Yeah, I would actually argue what's worse, like your website being down. I shouldn't say being down. Let's just say it's still up, but it's, one of your servers is down. So everyone's on one server if you have two. And it's so slow that, if you're like a shoe store, right, nobody could buy shoes because the site, just to respond, they give up and they go to another site and you lose the sale. And it might take you hours. But if you had the site down for 5 minutes because you had automation can just spin up a new server, and it's down for 5 minutes, but it's right back up and running again at full speed, then you're not going to lose as many sales, despite for the fact that people hate downtime. I get it. If the metric is downtime, you fail because you're down. But if you look at the sales and accessibility of the site, that's really important too. And 5 minutes isn't all that bad, depending on the industry, depending on what type of company it is. you got to really look at that, because if your automation scripts gets a new server up and running in 5 minutes, then why suffer, a longer period of downtime just to replace another server that way? So there's kind of like a give and take there, I think.
Yeah. At the end of the day, you can actually rely on both of them. You can have the site a bit slower, and on the other hand, be running the automation script that will bring another node up and just add it to the highly available cluster, and nobody will notice. And suddenly it was slow, and then the next moment it's no longer slow, and the load is starting to be divided again.
Yep.
And that's the ideal scenario right there. You're using high availability for the right purpose because you had a failure that you were not expecting, and now you're using automation to get everything back up again. In this case, adding back the nodes that were failed and getting them running again. And that's the best use case and the best scenario that you can describe for high availability. It provides the service continuity that you need. It provides at least some measure of service to your end users. And then automation, on the other hand, will bring everything back together again.
I'm glad you brought that up, because when, I mentioned cloud at the point I'm at in my descriptions, it's the same problem, just a, virtual manifestation of that. But then you start to get some additional benefits in cloud that you technically can't have with physical, which is auto healing and auto scaling, where, auto scaling is where, let's just say you have a new product that's released. So you're going to get more visitors than normal. And you have something watching the CPU on your servers. Maybe you have 3 of them, and they're getting to be like, 80% used or whatever your metric is. Then it'll spin up another one via, your automation scripts will be built into the image or however you do it. Or maybe you have the scripts built into the platform, and it builds an identical server quickly and puts it in the pool. And if people keep going to your site, it's super busy. It'll keep adding and adding and adding and adding to handle the load. And then when the load dies down, it'll actually delete servers down to a certain amount. That's really good. But then when you look at auto healing, which is, pretty much directly tied to this, you can start to delete servers. I'm not saying anyone should do that, but if a server got deleted, for example, a new one, you'll have a minimum number of servers. Maybe minimum is 3. So if you're down to 2, then your cloud platform is configured to automatically spin up another one to meet the minimum of 3. You can have a maximum in case, you don't want this to keep spinning servers infinitely. If there's a problem or a raise condition, you can have like a $20,000 extra bill on your hands to deal with. So you have to have a limit.
Yeah.
But getting back to high availability, though, when you're talking about application upgrades, that's another reason why people do this. Going back to physical, what that might look like is you take one server down, you update it to the new version of the app, and you just hope that the other server is going to last with all that load while you do it. And then you put that one in production. You take the first one down and you upgrade that one. So for a while, you're on one. That's not really an ideal situation, but people do that. And that's how a lot of times people will do what's called a rolling upgrade, where there's no downtime, but they do need to get you to that new version. Whereas with auto scaling, and I've done this in my career, where we roll out a new version and we just update the image, and then we just delete one server, and then that one is replaced by a replacement with the new app. Then we do the same for the second, and eventually they're all replaced. But as we were talking before we hit the record button, you brought up a really good point that whole process can take a lot longer than a maintenance window, depending on how
Yeah, absolutely. Because there are more moving parts, basically. You have to update the service. You have to make sure it comes back up again in a state that's compatible with whatever is already running on the other node. You have to make sure everything is synchronized again. You have to test the deployment to make sure that, some setting changed its configuration, its parameters or something like that, and it's complaining at start now when before it would just start up and start running. There are those countless issues that may come up during one of these upgrades. And of course, everybody tells you that you should have this test deployment and this lab deployment, and you should run all the tests beforehand. But at the end of the day, there are issues that will only come up on production systems. Maybe the new version that was supposed to fix all the problems now can only take half the load that it used to take before. Maybe it's slower, maybe it changes some slight configuration, and now the database has to be in a different format or something. These are the types of things that happen in production, that actually happen in real life, and sysadmins with some years of practice will have probably already encountered these issues. And when you're running a highly available service and you're relying on it to cover for you whenever that sync happens, it might take days to fix and to get the other end back up again. And during that whole time, you're not highly available and your service is very fragile at that moment. So if something happens and something unexpected happens on the node that's holding all the services at that point, that's when the service will fail, and it will fail hard, and then you will not have anything to fall back to. And that's basically the hidden side of high availability. And you always see it being touted as the solution for all of these issues, for never seeing the services go down again and all that. But then they leave these small issues in the dark, and they leave people in the dark about it. And you will only find them if something goes wrong, and you probably won't have much guidance when something goes wrong. You'll have to fix it yourself.
Yeah, it's just a trade-off. I think it's important to always use critical thinking skills, especially in this industry, when you see a product that's for sale that might solve a problem. And to be fair, maybe the product will solve that problem. But don't be overconfident in it either. If there was one solution that resulted in zero downtime, zero slowness, you better bet everybody would be doing it.
And there'd be the only thing.
It would be the only thing.
Yeah.
And you would have entire companies that would come up to exist just to convert companies over to this best way to do it. Believe me, if you could, market that and sell it and it was legit, like it would already be done. And what makes this hard is that every business is different. So we were talking beforehand about, my business. I am less reliant on my websites than I think most companies out there, because that's not where the majority of my revenue comes from. So there's been times where my website has been down, unfortunately, because I'm only one person right now, but I got it back up and running quickly because, I think it's like 5 minutes or so to restore one of the websites. And I don't have a bunch of retail products there. I have like blog posts sometimes that are written a month ahead. So they're time stamped. So if I do restore a backup from 2 weeks ago, nobody would tell the difference. But unfortunately, I'm like the 1% here. Most people are not in a business where, downtime doesn't matter. It does for most people. And you have to understand how much of it you want to engineer. How much of it are you going to spend? But how much is your downtime? Don't overspend to the point where you're spending more money than it would take if you were down completely. Like we were saying earlier, get your automation scripts going. Like that is the best thing, not just because it gets you up and running quicker. I'm a big champion of automation for another reason, which is human error. We're human. We make mistakes. We all make mistakes. Every single one of us. You will absolutely make a mistake. You have a typo, a period in the wrong place. You forgot a semicolon somewhere. We all do it, right? So if you have a script to automate something, whether it's Ansible or Puppet or Chef or whatever, then it's going to be created the same way every single time. You're not manually typing the commands and risk rm-rf, the wrong thing, right? You have the script, it's going to make the thing happen. That's a very good thing too. So automation, don't be overconfident in high availability. You should have it, yes, but don't think that it's going to save you from everything. I feel like, in a lot of ways, and let me know if you think the same way, that the failures that we have in hardware are similar in software, and on a level that's weird, because if you think about, or I was thinking about RAID when you were talking about some of the high availability problems, right? You're on one node and you're running off that one node while fixing the other one, hoping that the first one isn't going to go down. Yeah. Like with hardware RAID, RAID 1, like a mirror, your other hard drive goes, but it's okay. You're running off of one. But if that hard drive goes, you're really hoping that the other hard drive resyncs, and you don't lose both. Kind of like the same thing with high availability. One server's down, if it's physical, especially bad, because it could have came from the same assembly line with the same manufacturing issue. That's a real problem that you have to keep in mind, that it could happen, and it might not save you every time.
Yeah, and the point that I think people should take out of this is that you should obviously rely on high availability, but do it for the reasons that it was intended to cover for unexpected
Yeah.
errors and mistakes and hardware issues and stuff that you cannot anticipate. If you're using it to cover for operations that you can anticipate, that you should have the maintenance windows for and all that, then high availability is not the right solution for your problem. You should look at other ways to solve the issue that you're trying to solve on that maintenance operation, rather than counting for high availability to cover all of that. Because you're weakening high availability whenever you're taking nodes out of the system. And if you're doing it intentionally, then you're the one that's at fault for weakening your own platform and your own architecture. You should not do that, obviously. You should not
Right.
make your systems weaker on purpose. And that's what you're doing when you're using it to cover for maintenance.
What's the name of that study? I'm trying to think of the name that people, I'm losing my words, people do when they want to know the value of a solution to a problem versus the actual problem. Like there's an analysis that you do to make sure that you're not over analyzing or over engineering something based on the problem, and that you're actually keeping your metrics in check. Like this solution will solve these problems potentially, but you have these other problems. Seems like there's a word for that. I forgot what it is, but you have to know what problems are going to possibly come up and what to do about them.
Yeah, I can't recall the name. There is a name for that. I can't recall
Yeah.
it off the top of my head.
Something study. Yeah. That doesn't help.
Whatever, it doesn't really matter.
No, it doesn't.
It doesn't really matter. But the main idea is that to use high availability to spread the load of your systems, to don't have a single bottleneck on the system, to avoid single points of failure, but then don't weaken it on purpose and create those points of failure yourself. Rely on high availability for the right reasons.
Yep. And I also like how these solutions build on each other, because I feel like that's one of the most fun aspects of the job, because it's almost like the Unix philosophy where you do one thing and do it well and you could chain things together. It's the same way here, because you could literally have a, you have your Ansible automation. I just say Ansible because it's my favorite. I'm biased, I admit it. But, you that could spin up a server, get everything configured in 5 to 10 minutes, which is a lot better than if you had a high available, system, but you had to manually get the other node running by installing the OS, installing the updates and the packages and the config files. And then next thing you know, you're spending the entire day doing that, which means your risk has increased the longer that it takes you to get the other server going. Whereas if you had Ansible or Puppet or Chef or whatever your favorite solution for this is that can just build it for you, if it's physical, maybe you might install the OS, but then you run the script and, that's a heck of a lot better. And then there's also Metal as a service that will provision physical servers as well. So that could be automated. Even if not, in cloud, you have Terraform that could build things. You have Packer, which can automate the image building process. So these things all combine, and together, high availability with automation is better than just high availability. So when you start adding these things together and really think about your overall infrastructure, and have a balance between, not over engineering it, but not under engineering it, and making sure you have a disaster recovery plan and disaster prevention plan, all those things together are what's going to help you out, not any one of those things.
And I just want to say one final thing here, because I know some people are already writing the comment, oh, but you're using just the 2 nodes as an example, and that's the extreme. And if you have 10 nodes, that's no longer an issue. It's still an issue. If you have 10 nodes for a service, it's because you either need the performance of those 10 nodes to serve the request that you have, or you have some other requirement that asks for 10 nodes. You wouldn't just buy 10 servers for one service that could run on 2. Right. So whenever you're taking nodes out of that system, you are weakening the whole system. You might not create a single point of failure, but you will reduce the performance of the other ones. So the same logic applies here. You're weakening your system on purpose if you're not using high availability to cover just for unexpected issues.
Right. And your cost goes up. If you have those 10 nodes and you're barely using half of them at any one time, your high availability solution is great. You're really never going to have a problem, or very unlikely to have a problem, I should say. But you're also, managing more physical servers. If it's physical, if it's virtual, your bill goes up is the difference. Either way, you're spending more money. And then if you look at how much money, like if you did this for 5 years, and let's just say hypothetically, you had no issues in 5 years, that'd be pretty weird. But let's just assume like everything's been perfect for 5 years, nothing has gone down. Then you might have had like one hardware refresh during those 5 years. So you bought the servers and then you refreshed them. How much does that cost? Because you didn't really need it. Now, of course, you can't tell the future, right? Because you don't know, oh, well, if I'm not going to have a problem, and people assume they're not going to have a problem, that's why they get into problems, but you don't really know. So if you over-engineer something, yeah, great, that's the machine gun approach. You're probably in a better position, but you're probably letting other things go in your company that really needs attention from the budget, because there's going to be, users complaining about desktop computers they're using from 8 years ago because you're putting all your money into high availability. I can go on and on and on. It's
and even power and cooling costs.
Yep.
Those servers will have to be powered all the time. Will have to have appropriate cooling running. So you'll have to have high cost HVAC systems there. All of that adds up over time. So you don't want to put extra load there if you don't have to. Over-engineering that high availability system will make those costs go up.
And there's other time that you could be spending too, because one of the companies I used to work for, I think it was like 10 or 12 minutes for a server to provision. And this is cloud, by the way. And then that was okay. But then later on, we had some time to invest, or we decided to invest time into looking at making that quicker. And then we shaved it down to like 5 minutes for the provision. And I'm pretty sure we got it down to 3. And that work is going to be, in my opinion, exponentially better than over-engineering another solution, because you can get back up and running in 3 minutes. I mean, let's not underestimate the value of that. Yeah, you'd rather never be down, but you could have a problem when you're trying to spin things up, or especially if you're not using auto-scaling. There's basically, we could go on about the pros and cons and quirks all day long. The point is, in my opinion, to have a balance on what you focus on and make sure that you're using things effectively, not overusing things, and not taking attention away from things that desperately need your attention. So that way you have a more well-rounded system, rather than you're super protected from A, but you're not protected from B. You don't want to be in that situation, because if B happens, then that's going to be a very bad day for your job.
And there's a complexity increase here as well. It's harder to track more complex things in your mind. It's harder to grasp how they work together, how they interact with each other. And the less systems that you have, the less things that you have running together or interacting with each other, the easier it is to keep track of everything. So there is also that factor that plays in. And you have to remind yourself that it's going to be humans that are going to be looking after those servers, whether it's in the cloud or it's on premises or whatever. You might have all the scripts and all the automation and all that, but then somebody has to actually know what's going on, and somebody has to step in if something doesn't go according to plan, and that person has to understand the system and the solution. And over-engineering things just complicates the whole system.
It really does. And sometimes I feel like it's not even the choice of the administrator. Like, they focus on what they have to focus on because that they're just doing their job. And if their CTO says, this white paper says we need to do X right now, but hold on, we have like these actual problems over here that we really need to fix. No, stop working on that. Microsoft says in this white paper, we need to do this. So we need to drop everything and do this. And then, the administrator's rolling their eyes like, really? Like, you're not listening to me. So I get it. It's like I keep putting it on the administrator, but it's really not the case, because it's a shared responsibility in the company that even the non-technical people at least have an understanding of what the focus should be on and what the benefits are, even if they don't know how to do it. So that way everybody understands the bigger picture, rather than, being reactionary to everything, which is unfortunately how a lot of people are out there.
So true. So true.
Yep. All right. Well, I think that was our podcast. This is a fun episode. What a great way to start the new year. This will get a lot of people thinking. I think everyone that hears this, they might think of something in their own environment they might want to change the thought process on, or maybe there's something they really need to get their CTO to listen to. Maybe they can just point them over to this podcast and they wouldn't even have to explain anything. Just say, just watch this or listen to this podcast and that'll explain it, is what I'm hoping anyway.
Yeah, that would be great.
All right. Well, thanks everyone for watching, listening, or however you digest this content. We're excited for another year, our first full year of this podcast, which would be great. And lots of exciting episodes to come.
Sure. And until the next one, everybody.
See you later.